Okay, let's solve this problem in 37 in different way, because you see it's very complicated. So we are solving first using cofactor formula, so the inverse matrix. After we using row elimination, Gauss-Jordan process is the name, the technical name of this. It's two different ways to get. And finally, we are using graphical calculator to see the result. Okay, the first step is compute the determinant of the matrix. Okay, let's expand using cofactor formula. As always, row number 1, why not? Is 1 times this determinant is minus 2, 1, minus 3, 0, plus, because it's negative and negative is positive, and when you expand this, we have 0, 1, negative 2, and 0. And the last is 1 again, is plus, determinant is 0, negative 2, negative 2, and negative 3. Okay, now multiplication. Multiplication this and this, multiplication this and that. Is 0, 0, and plus 3. Multiplication this and this is 0, multiplication this and this negative is plus 2. And multiplication this and this is 0 again, and multiplication this and this is minus 4, because 2 times 2 is 4, 3 negative is negative. So is 3 plus 2 is 5, minus 4 is 1. Determinant is 1. Okay, it's different to the 0. It's non-singular, therefore the inverse matrix exists. Okay, let's continue with the equation 37. In this case, I want to find the cofactor matrix. In this case, it's super complicated because it's 3 by 3. For example, the cofactor 1, you delete this and this, and you have this determinant. And when you multiply, this is 0, and this is minus 3. The answer is 3. Okay, remember this is plus, this is minus. Double minus is positive. Cofactor 1, 2. Factor 1, 2 is you delete this and this. Then you have 0 and negative 2 is negative 2. Remember the sign when this 1 plus 2 is 3 is odd number, because we have extra negative here. So 1, 3, 1, 3 is 0. 1, 3, you delete this and this. This is the determinant, and the multiplication is 0, and this is negative 3, negative is negative 4. The cofactor 2, 1. Okay, obviously we have a 2 plus 1 is 3 is extra negative. 2, 1 is 2, 1 here. Delete this and delete that. 1, negative 1, 1, 3, you multiply is 0. So it's negative is positive, but the answer is 10, negative 3. Because it's negative 3 times another negative we have in this diagonal. It's positive, but it's 0, negative, and negative is positive, but according to the position, the cofactor is negative. Also 2, 2 here, 2 and 2 is positive and negative. Entonces es positive too. And C23. C23 is 2, 3. 2, 3 here. We have the determinant is negative 3 and negative 2. Entonces es like negative 5, pero according to the position is negative, entonces es positive 5. Positive 5. Now 3, 1. This is my determinant. It's plus here and minus here. Entonces negative 1 and positive 2 is 1 positive, but the sign is positive because 3, 1 is positive. It's 1. Now 3, 2 is this and this. Is 1 is 0. And according to the position is negative 1. Negative 1. And 3, 3 is 3, 3. Es this determinant. Entonces minus 2 and plus 1. Entonces negative 1. Negative 1. Okay. Entonces now the cofactor matrix will be then, cofactor matrix is 3 minus 2 minus 4 minus 3 2 5 1 negative 1 and negative 2. No. Negative 1. This is negative 2 here. And negative 2 because it's negative 2 and 0. This is negative 2. So it's negative 1 and negative 2. Negative 1 is this and negative 2 is this. This is the cofactor matrix. And the cofactor transpose is you change, for example, this row or this column 3, negative 2, negative 4, minus 3, 2, 5, and 1, negative 1, and 2. And this is a coincidence that is equal the inverse matrix because the determinant is 1. Okay, this is one way to determine. It's complicated and long. Okay, another way to find the inverse is using the method of it's called a Gauss-Jordan method. Yes, you copy the matrix original here, you copy here the inverse. So basically, you copy the original matrix, and you form the augmented matrix using the original and identity. In this case, it's identity 3 because it's 3 by 3. And you perform row operation until you transform this in order to get identity matrix in this side, and you have the inverse matrix in the other side. Okay, this is a Gauss-Jordan method. Okay, this is the idea. Okay, let me try. It's too long also, but I want to do at least one time. Okay, so this is the first pivot. Fortunately, this is 0, not necessary to do anything. So now you convert this to 0. Entonces, opposite number que es 2 R1 plus R3 store in R3. You perform this row operation, and the new matrix will be then 1, negative 1, 1, 1, 0, 0, 0, negative 2, 1, 0, 1, 0. This is staying. The only change is the third row. It's 0, negative 5, 2, 2, 0, and 1. Because 2 times 1 is 2, 2 minus 2 is 0, 2 times negative 1 is negative 2, and negative 3 is negative 5, 2 times 1 is 2, plus 0 is 2, 2 times 1 is 2, plus 0 is 2, 2 2 times 0 is 0 plus 0 is 0, and 2 times 0 is 0 plus 1 is 1. Now let's continue. Let's do it quickly because I suppose that you know row operation and the other. I don't know. I finished this column. Now I need this pivot 2. So you divide it. Row 2 divided by negative 2 and store this information on the row 2. Entonces is 1, negative 1, 1, stay the same. The only change is row 2 que es 0, 1, negative 1 half divided by negative 2. 0, negative 1 half, and 0. And the rest stay the same. Okay. Now, let's do the next row operation, que here is 5. 5 R2 plus R3 is stored in the new R3. Entonces is 1, negative 1, 1, 1, 0, 0, 0, 1, negative 1 half, 0, negative 1 half, 0, and it's changed, of course. This is 0, 0, negative 1 half, 2, negative 5 over 2, and 1. Okay, let's continue. Now I propose R2 plus R1 store on R1 because I want 0 here to complete the second column. So the transformation is okay. Row 3 and 2 stay the same. The only change is row 1. In this case will be 1, 0, 1 half, 1, negative 1 half, and 0. Okay. Again, I need 1 here and this pivot, so I multiply by negative 2 row 3 and store in the new row 3. When you multiply by negative 2, we have then 0, 0, 1, negative 4, negative 5, and 1. And the rest stay the same. Now using this pivot, you multiply by 1 half R3 plus R2 store a new R2. So we have then 0, 0, 1, minus 4, minus 5, 1, 0, 1, says 0, 1, 0 here, minus 2, minus 2, 2, negative 1, so here we have the same, 1, 0, 1 half, 1, negative 1 half, and 0. Entonces finally we have 1 here, no, 0 here. So we apply this using this pivot, negative 1 half R3 plus R1 store and the new R1. Okay, let me erase this part to do this last part. When you perform this row operation, we have is row 3 stay the same, row 2 stay the same, and row 1 change is 1 0 1 3 negative 3 and 1. And this is the inverse matrix. Okay. Okay, now let's see the problem using the calculator. Okay, of course, to save time, I put the original matrix in the matrix A. Is this? This matrix is this matrix. Okay, now let's find the inverse. The inverse, remember, is this key inverse, and this matrix is the inverse is this matrix. Exactly, we found using two different methods by hand. Store this matrix in matrix B, and B we have the inverse, and clear, and you multiply matrix A times matrix B. I suppose que we get the identity matrix of the dimension 3. There you go. In different order. Matrix B first times matrix A. Same thing. Perfect. This is the verification.